Problem 23 presents us with a word problem. A merchant plans to mix two types of corn. One type costs $2.50 per pound, and the other costs $4 per pound. How much of each type should be mixed together to create a 10-pound bag that costs $30? So to solve this problem, I'd like to decipher the text, turn it into some algebraic equations, and then solve those equations. We're actually going to end up with a system of equations. A good place to start is to think about what we don't know. So what we're being asked to find is how much of each type should be mixed together. So let me start by creating variables for those unknown quantities. I'm going to let x equal the amount of type 1 corn. So that's the $2.50 variety. And I'm going to allow y to equal the amount of type 2 corn. So the $4 variety. Using those variables, I can set up two equations. On the one hand, I know the total mixture should be 10 pounds. That gives me the equation x plus y equals 10. I need the two amounts to add up to equal 10. And I want the price, of course, to be 30. To calculate the price, I can take these two amounts, $2.50 and 4, and include those in my equation like this. 2.5 times x plus 4 times y have to add to equal 30. Now, to solve the problem, I want to solve these two equations simultaneously. I want to solve this system of equations. So to do this, I'm going to multiply the first equation by negative 2.5. I'm going to multiply all of those terms. That gives me negative 2.5 times x minus 2.5 times y equals negative 25. My second equation, I'm going to keep the same, positive 2.5x plus 4y equals 30. And now, what I can do with these two equations is add them together. That will eliminate the x term because they have opposite coefficients. So this method is sometimes called the addition method because we're adding the two equations together, but we're doing it to eliminate one of the variables. So that's why I tend to call it the elimination method. What we end up with is 1.5y equals 5. And that's a simple linear equation. We can solve that to see that y has to equal 5 over 1.5. And we can simplify that fraction. If I double the top and the bottom, I get 10 over 3. But also, because this is an applied situation, it might make more sense for the merchant to think about this as a decimal number. So the value that we're looking for is really approximately 3.3. Okay, well, we've made some progress, but we're not quite done. I need to take this value for y and plug it back into one of the equations. Let me plug it back into this first equation and find the corresponding value for x. So we get x plus 10/3 equals 10, which means that x equals 10 minus 10/3. But I can think of 10 as 30 over 3, and if I subtract from that 10 over 3, I'm left with 20 over 3. So the value for x must be 20 over 3, or as a decimal value, approximately 6.7. So those are my two values. The value for y is 10/3, the value for x is 20/3. Those are the two values that should satisfy both equations simultaneously. It makes sense to double check this and think carefully if this actually works out. So if I add these two together, if I add together 20/3 plus 10/3, I get 30/3, which equals 10. So that satisfies the first equation. Regarding the cost equation, I can take 2.5 times the x value, 20/3, and add that to 4 times the y value, or 10/3, and that gives me 50/3 plus 40/3, which is 90/3, which equals 30. So the cost equation works out too. So these are my two solution values. But one last thing, because this is a word problem with a context, the merchant and the corn, let's put it back into a sentence that acknowledges that context. The merchant should mix 3.3 pounds of the cheaper corn with 6.7 pounds of the more expensive corn. And of course, in the answer here, I use the approximate values. The mathematical solution is 20/3 for x and 10/3 for y.